So for this question, we have a 20-year-old male that comes in with easy bruising. He says he gets injured easily, and when he had his wisdom teeth removed, there was a lot of bleeding that took a long time to stop. Labs are done and show prolonged PTT and prolonged bleeding time. What type of bleeding disorder does he have? So A, disseminated intravascular coagulopathy, so DIC, B, hemophilia A, C, vitamin K deficiency, or D, von Willebrand disease. So I'll let you answer the question and then I'll explain. Okay, so the answer is going to be D, von Willebrand disease. So for this question, we can review all the different types of abnormalities in blood tests when we are looking at these different bleeding disorders. So we'll start with hemophilia. So hemophilia A or B, which is going to be factor 8 or 9 deficiency respectively, is going to cause a problem in the intrinsic pathway. So just to review, this is PT, so prothrombin time measures the extrinsic pathway. So you're really just looking at factor 7. PTT is the rest of the coagulation cascade. So you're looking at, for example, in hemophilia A, factor 8, and so that's going to be impaired. So therefore, PTT is going to increase. Platelets, we're just looking at platelets, and bleeding time is measuring the time it takes for a clot to appear. So it's looking at primary hemostasis, which is platelet aggregation and adhesion. And so going over these, like I said, since we have factor 8 or 9 in hemophilia A or B causing this, we're going to have an increase in the PTT. For von Willebrand disease, we're also going to have an increase in PTT and an increase in bleeding time. Now, this is because von Willebrand disease happens when you have the von Willebrand factor binding to exposed collagen when you have endothelial damage. And the thing is, von Willebrand factor is also holding on to factor 8 to prevent its degradation in the blood. And so, since both of these are going to be impacted, its ability to bind to the collagen and therefore it attracting platelets, it's going to lead to an increased bleeding time. And then the factor 8, is going to cause an increased PTT. Now, DIC causes a wide range of abnormalities. So it's going to cause an increased PT, increased PTT. So it's going to cause increase in both the extrinsic, it's going to cause impairment of both the extrinsic and intrinsic parts of the coagulation cascade. And then we're going to have decrease in platelets because a lot of the platelets are going to become sheared. And then finally, because you're having a decrease in platelets, you're also going to have an increase in bleeding time. And finally, we have vitamin K deficiency. So that's going to increase both PT and PTT. Now remember, vitamin K has the factors 2, 7, 9, 10, and protein C and S. And so notice how I said 7, so that's going to increase the extrinsic pathway. And for the PTT, all the other ones that I listed were part of the intrinsic pathway. So PTT is also going to be increased. And then finally, platelets and bleeding time are going to be normal because I didn't mention anything regarding platelets. So just to summarize, we have hemophilia A, like I said, factor A deficiency, part of the intrinsic pathway. Vitamin K deficiency can be warfarin, induced by warfarin, since warfarin's mechanism of action is blocking vitamin K epoxide reductase. And so this is the crucial enzyme that helps process vitamin K. And without it, you're going to lose the ability of vitamin K to gamma carboxylate the rest of these. And so just to review the coagulation cascade with you, we have first the injury to the vessel, and then we have factor 12, and then the A just stands for activated. So we have 12, and then we go down to 11. 11 goes down to 9. Factor 8's in the middle right here. And then so from 9, we go down to 10, or I'm sorry, I guess we go up to 10. And then finally we go to 5, 2, which is represented by prothrombin, and then once it becomes activated, it becomes thrombin, and then finally we have fibrinogen, and then becomes activated into fibrin. And so finally we have cross-linking, which is done by factor 13. And then this was all the intrinsic pathway, and then this is going to be the extrinsic pathway. So tissue factor is going to activate factor 7, which is part of the extrinsic pathway, measured by the PT time. So in summary for this question, you had to know essentially the different bleeding disorders and their effects on the labs, specifically the blood labs. And so for this one, it's going to be D, von Willebrand disease, because that's the only one that's going to increase the PTT because of the intrinsic pathway, because it holds on to factor 8, and it's also going to affect platelets because von Willebrand disease helps bind to collagen, which then helps bind to platelets. And if it can't do that anymore, then you're going to have essentially a dysfunction between the platelets and and their ability to clot. And so that's going to increase the bleeding time. So I hope that helped, and thanks for watching.